Boeing 777X, the future of long-haul aviation. The Boeing 777X is the newest generation of Boeing's famous wide-body passenger aircraft and represents one of the biggest technological advancements in commercial aviation. Designed as the successor to the highly successful Boeing 777 family, the 777X combines advanced engineering, greater fuel efficiency, improved passenger comfort, and outstanding long-range performance. Developed to meet the growing demands of modern airlines, the Boeing 777X is built to carry more passengers over longer distances while reducing operating costs and environmental impact. With its revolutionary carbon fiber composite wings, powerful GE9X engines, folding wingtips, advanced flight deck, and spacious cabin, the Boeing 777X is expected to become one of the world's most important long-haul airliners for decades to come. The Boeing 777X program was launched to build upon the incredible success of the original Boeing 777, one of the best-selling wide-body aircraft in aviation history. Engineers carefully studied airline requirements, passenger expectations, and future aviation technology before creating the 777X. The result is an aircraft that combines the reliability of the Boeing 777 with innovations inspired by the Boeing 787 Dreamliner. Every component has been redesigned to improve efficiency, safety, and performance while maintaining the exceptional reputation of the Boeing 777 family. One of the most striking features of the Boeing 777X is its enormous carbon fiber composite wing. Unlike traditional aluminum wings, these advanced composite wings are lighter, stronger, and more aerodynamic. The wingspan measures approximately 71.8 meters, making it the largest wing ever installed on a commercial airliner. Because many airports cannot accommodate such a large wingspan, Boeing introduced an industry-first innovation for commercial aircraft, folding wingtips. When the aircraft is on the ground, the outer sections of the wings fold upward, allowing the aircraft to fit standard airport gates. Once airborne, the wingtips lock into position, providing maximum aerodynamic efficiency throughout the flight. Powering the Boeing 777X are two General Electric GE9X turbofan engines, the largest and most powerful commercial aircraft engines ever built. These engines generate incredible thrust while consuming significantly less fuel than previous generation engines. Advanced ceramic matrix composite materials, lightweight construction, and improved fan blade technology help reduce fuel burn, lower emissions, and decrease operating costs for airlines. The GE9X engines also operate much more quietly, improving the passenger experience and reducing airport noise pollution. The Boeing 777X cruises at approximately Mach 0.84, allowing airlines to transport passengers efficiently across continents and oceans. Depending on the variant, the aircraft offers an impressive range of more than 16,000 kilometers, enabling non-stop flights between many of the world's most distant cities. This capability provides airlines with greater flexibility when planning international routes while offering passengers faster and more convenient travel. The aircraft is available in two primary variants. The Boeing 777-9 is the larger version, designed to carry between 384 and 426 passengers in a typical two-class configuration. It is currently the largest twin-engine passenger aircraft ever developed. The Boeing 777-8 offers slightly fewer seats but significantly greater range, making it ideal for ultra-long-haul routes connecting cities separated by thousands of kilometers without intermediate stops. Passenger comfort has been dramatically improved throughout the cabin. Inspired by the Boeing 787 Dreamliner, the Boeing 777X features a wider cabin, larger windows, improved cabin humidity, lower cabin altitude, quieter interiors, and advanced LED mood lighting. These features reduce passenger fatigue during long flights while creating a more relaxing travel environment. Airlines can customize seating arrangements across first class, business class, premium economy, and economy class while maintaining generous cabin space. Large overhead storage bins provide additional luggage capacity, helping passengers store carry-on baggage more easily. Improved air filtration systems continuously circulate fresh air throughout the cabin, enhancing comfort during long international journeys. Advanced climate control systems maintain consistent cabin temperatures regardless of external weather conditions. Inside the cockpit, pilots benefit from Boeing's latest digital flight deck technology. Large high-resolution displays provide clear flight information while advanced flight management computers assist with navigation, performance optimization, and aircraft monitoring. Modern fly-by-wire flight controls improve handling characteristics and reduce pilot workload. Numerous automated safety systems continuously monitor aircraft performance and provide additional protection during every phase of flight. Safety has always been a top priority for Boeing, and the 777X incorporates the latest advancements in aviation safety. Multiple redundant flight systems, advanced weather radar, terrain awareness systems, collision avoidance technology, automatic flight control systems, and sophisticated engine monitoring all contribute to an exceptionally high level of operational safety. The aircraft has been designed to meet or exceed the strictest international aviation regulations. Aerodynamic efficiency is another major strength of the Boeing 777X. Engineers optimized every curve of the fuselage, wing design, engine nacelles, and tail surfaces to minimize drag while maximizing lift. These improvements contribute directly to lower fuel consumption and greater operating efficiency. Combined with lightweight composite materials, the aircraft delivers significant cost savings for airlines while reducing environmental impact. The Boeing 777X also benefits from advanced maintenance technology. Thousands of sensors located throughout the aircraft continuously monitor engines, hydraulics, electrical systems, environmental controls, and structural components. Predictive maintenance software analyzes this information and alerts maintenance crews before small issues become major problems. This technology reduces unexpected downtime, improves reliability, and lowers maintenance costs over the aircraft's service life. Cargo capability is another important advantage. Beneath the passenger cabin, the Boeing 777X offers a large cargo hold capable of transporting significant amounts of freight alongside passenger luggage. This additional cargo revenue makes the aircraft even more attractive for international airlines operating long-distance routes. Many of the world's leading airlines have placed orders for the Boeing 777X, recognizing its potential to become the flagship aircraft for future international operations. Major carriers from the Middle East, Asia, Europe, and North America have invested heavily in the program. Airlines value its combination of high passenger capacity, exceptional fuel efficiency, long range, and reduced operating costs. Environmental performance has become increasingly important in modern aviation, and the Boeing 777X has been designed with sustainability in mind. Improved engine efficiency, lighter construction, advanced aerodynamics, and modern manufacturing techniques help reduce carbon dioxide emissions compared to previous aircraft generations. These improvements support the aviation industry's long-term goals of reducing environmental impact while meeting growing passenger demand. Beyond its impressive technical specifications, the Boeing 777X